We move to the part to talk about trigonometric equations, right? Now the first skill is that if we know one trigonometric function, we can find the other two. For example, if we know sine theta, then we can find cosine theta and tangent theta. So let's take a look at this example. We know that sine theta is 3/5, right? And theta is a second quadrant angle. So we want to find cosine theta and tangent theta. Now, before I tell you the correct way, do not do it in this way, right? You are tempted to find theta using the calculator. That will be the arc sine of sine theta 3/5, right? If you do it on the calculator, that would be 36.87 degrees. So that cosine theta will be cosine 36.87 degrees, something like that, right? Don't do it in this way, all right? My advice is not to do it in this way. Because if you do it like this in blue, then you have an approximation value only. This is only an approximation. You will never get the exact value. Alright. If it demands an exact value, then it is better to do it in the two methods I propose. Alright. You can do it with an algebra method. We can do it with algebra. Or we can do it with geometry. Let's first look at the algebra method. In the algebra method, we make use of the trigonometric identity, say sine square theta and cosine square theta is 1. And we have tangent theta is sine theta over cosine theta, right? So we use formula like this to help convert between sine, cosine, and tangent. And also we can use the CAST information to help fix the plus and minus sign. For example, in this one, we have cosine square theta will be 1 minus sine square theta. Alright, knowing that sine theta is 3/5, so that is just 1 minus 3/5 square, and that turned out to be 16/25. This is cosine square theta. So you take the square root, cosine theta will be 4/5 plus minus. Alright, so shall we take the plus or the minus? Depends on the quadrant. Alright, notice that it is a second quadrant angle. Right, it is a second quadrant angle. So we have sine theta is positive, but cosine theta will therefore be negative. Alright, it is CAST. It is the second quadrant, so cosine theta should be negative. We shall reject this one. So at the end we have cosine theta is minus 4/5. Finally, for tangent is sine over cosine. Tangent theta is sine over cosine, and that is 3/5 divided by negative 4/5. So it's minus 3/4. This is tangent theta. Alright. So in other words, the algebraic method, we make use of the formulas, the theorems in the green box, and then we can convert between sine, cosine, we can convert between tangent. Alright, and the most important thing is to note the quadrant here. The quadrant will tell you what are the plus and minus for the other trigonometric function. Alright, so naturally tangent theta will be negative in the second quadrant. Alright, okay, so that is the algebra method, right? There's another method. We can do it with geometry. We can do it with geometry. We use right angle triangle. Alright, when sine theta is 3/5, we can now it says theta is second quadrant, but in this geometry method, never mind. Let's assume theta is AQ. Alright, assume AQ angle theta, so we can draw the right angle triangle. In that case, sine theta will be 3/5. Alright, so we can invoke Pythagoras theorem to find out the remaining side. The last one will be 5 squared minus 3 squared equals to 4. Alright, so we know this line is a 4. Now we can use this right angle triangle to do cosine. Alright, cosine theta will be 4/5. Right, the adjacent side divided by the hypotenuse. But once again, we can use CAST to decide. It is a second quadrant angle, so cosine theta should be negative in the second quadrant. Alright, so use CAST. We decided that cosine theta shall be the negative of 4/5. Alright, and likewise from the same right angle triangle, we obtain tangent will be 3/4. And then from the CAST, in the second quadrant, tangent should be negative. So we put back the negative sign here. Alright. So this is how we use geometry. We assume it is an acute angle, alright, and then we draw the corresponding right angle triangle, and finally use CAST to design the plus and minus. Okay. So let's take a look at another example. We have tangent theta is -2. Alright, theta is in fourth quadrant. So what is sine theta and cosine theta? Alright, let's do it in both ways. So perhaps we do it the geometry way first. Alright. Now assume tangent theta is a right angle triangle. Assume tangent theta is an acute angle, right? So we have tangent theta is -2. Never mind the minus for the time being. Just focus at the 2. We have tangent theta is 2, so it's 2 to 1. Pythagoras theorem gives that the hypotenuse shall be 5, right? Assume this is the angle theta. So now we have sine theta will be the opposite side divided by the hypotenuse, alright? But it is in the fourth quadrant, so CAST, the fourth quadrant, sine theta should be negative. So this answer, sine theta, goes to -2 over square root 5. If you want to rationalize it, it is the negative of 2 over 5 square root 5. Both are acceptable answer. And similarly, from the right angle triangle, we can get cosine theta will be 1 over square root 5, alright? The adjacent side divided by the hypotenuse. But it is in the fourth quadrant, so CAST, cosine in the fourth quadrant, should be positive. So cosine theta will be plus 1 over root 5, right? If you want to rationalize it, it will be root 5 over 5, alright? So this is how we did it with geometry. At the same time, we can deal with it with algebra. Alright, we know that tangent theta is -2, right? So tangent square theta will be sine square theta divided by cosine square theta. We can add 1 to it. Alright, we can add 1 to it so that we have sine square theta plus cosine square theta divided by cosine square theta. Alright, we can take the common denominator, and that is 1 over cosine square theta. 1 over cosine square theta. So which means that cosine square theta is 1 divided by 1 plus tangent square theta. Now, tangent square theta is -2, so this is 1 over 5. Alright. At the end, the algebraic method tells us that cosine theta will be 1 over root 5, plus or minus. Alright. And we choose to keep the plus because it is from CAST. Cosine in the fourth quadrant is plus. Alright. And by similar token, we have sine theta is tangent times cosine. Alright, because tangent is sine over cosine. So that is -2 times 1 over root 5. So we have -2 over root 5. So naturally, we come to the same answer. Okay, so this is the part on how to find one trigonometric function given how to find the other two trigonometric functions given one of them. There is a similar example. You can look at this one. Well, we have a point here, right? We have a reflex angle. Say the point is 4 root 3 and -4. Alright, say the point is here. Point A is 4 root 3 and -4. We have the reflex angle theta here. So the question is, what is sine theta, cosine theta, and tangent theta? Alright, what are these trigonometric functions? The theta is that reflex angle. Alright. So now, instead of considering the reflex angle, we can consider the 360 minus theta. Alright, how about this blue angle? This blue angle is 360 degrees minus theta. So we can consider sine 360 degree minus theta. Alright, is negative sine theta. So we have sine theta equals to this one. Alright, and similarly, cosine theta will be cosine 360 degrees minus theta. And tangent theta will be the negative of tangent 360 degrees minus theta. These plus and minus come from CAST. Alright, because it is in the fourth quadrant. So we have this CAST. And for the blue angle, 360 minus theta, we can use the right angle triangle to help us. Alright, we know that this is 4 root 3, this is 4, alright, and Pythagoras theorem gives us the hypotenuse should be 8. Alright, so we have sine theta will therefore be the negative of 4 over 8. Alright, cosine theta will be root 3 divided by 2, and tangent theta will be minus 1 over root 3. Alright, so in this way we can get, because it is from the ratio, of the lines in the right angle triangle. Okay, so this is the end of this part.